Good afternoon. I'm Mr. Ish. Thank you for joining me. We're looking here at exponential applications. But when you're looking at exponential applications, by the inverse aspect, you're also looking at logarithmic applications. We have here what is the formula for a continuous compound interest. Some of you will know it in this way. PT is equal to POE to the RT. Your principal, your amount of money at time t is equal to your amount of money, or your principal at time 0, your initial amount times e to the power of rt, where p here represents the principal, or you can use a for the amount. We have here rate is equal to 3%. Our question is exactly this. We're looking at continuous compound interest. What time is needed to double your money? You see how I've not given you your initial, nor have I given you your final amount of money, but you don't need it. You have to think everything here with regards to algebra. What time is needed? We're looking here for this specific value t. Without knowing these amounts, your principles, how can you go around with this question? You can. Think of this. Your initial amount is x. Your amount time at which the money is doubled will obviously be 2x. If you were to divide these, you're really looking at 1 and you're looking at 2. In terms of all practicality, your initial principal is just a 1. Your amount at time t needed is double, and you're looking here e to the rt. You're basically just looking here at this, and you know what your r is. Your r is 3%. The 3% has to be written here in terms of a decimal. 3% would be written as 0.03. You would just plug that value here. You can take the 1 on the other side. It's kind of meaningless. You're looking at really this. 2 is equal to e to the rt. Now let's clean this up and actually put in our values. We have our 2 equals rt 0.03 t. Now you have to bring in the properties of logs to solve this. You'll bring all of this right over here by bringing in the natural log. Natural log 2 is equal to 0.03 t. Natural log e, which is always equal to 1, and t here is equal to natural log 2 divided by 0.03, and you can do that. Natural log 2 natural log divided by 0.03, you get 23.1 years, because time with regards to compound interest is measured in years. If you had a rate of 3%, no matter what amount of money you had, $1 or $1 million or $1,000, it would take 23.1 years for money to compound continuously at a rate of 3% to double it. And that right there is your exponential application solved. Let's look at one more, and that'll be it for this specific video. Actually, before I end this, let me show you one specific thing. When you're looking here, right here, in terms of a graph, you're looking at nothing more different than this. F of x is equal to e to the x. Think about it. You just happen to have a coefficient here. Let's call that coefficient here a, e to the x. But here x is really represented by an rt. But in all actuality, you're looking at nothing more than an exponential function, except with regards to these practical applications in money, you would start your graph off from right here, because you would never have anything such as negative time. You would never have anything as negative money. Time in this direction, your money in this direction right over here, but your graph would look something like this. Okay, so keep that in mind. The fact that you have a positive value here indicates your money will grow with time. It won't get less, but it will grow exponentially with time. So keep the signs over here very clear. Our second question is the exact opposite in terms of exponential applications. Why is it opposite? Not because of these letters, but because of this negative sign. You see here we have something here which looks like f of x is equal to e to the minus x. When you're looking at something like this, you're looking at a graph and you have a coefficient here a or here n, but you're looking at something which looks like this. But in terms of practical applications, you have to cut it off right here, because you can't have negative time and you cannot have negative amounts or whatever, negative items. Everything here with regards to the x-axis time, you cannot have negative time. It's either 0 time and you go from there. Anyhow, you're looking at something like this, hence the minus indicates something will decrease with time versus something will increase with time, such as money increasing with time. But here you're looking at something which is becoming less with time, but it's becoming less exponentially with time. We're looking here at actually what is the formula of radioactive decay or nuclear decay, but instead of using those words, let's look at something which is decomposing or decaying with time. The amount or the number of atoms at time t, or the amount or the number of atoms at time initial or 0 is equal to e times minus rt. If our rate here is equal to 0.002, whatever that means, what time is needed for half the compound to decay or to decompose? Now how do you set this up algebraically? If you're looking at something to decay to half of its amount, the amount at time t must equal to half the amount at time initial, right? Because you're looking at the time needed for half of your original compound to decay or decompose. If your original compound is equal to NO, then your amount at time t must equal to half of that original compound, and this right here is the algebraic expression you use in this equation to convert both of these into one single variable. Plugging this in, we know now that NO over 2, right? Half NO, which represents this. NO over 2 is equal to NO, your initial amount, times e to the minus RT. But I know my R is 0.002 T. Look at this, you can cancel this out, because if you take this on the other side, it'll divide. NO divided by 2NO, the NOs will cancel out. You're looking at 1 over 2 is equal to e to the minus 0.002 t. Bring the natural logs, bring this exponent right here. You're looking at natural log 0.5, which is 1 over 2, is equal to minus 0.002 t natural log e. This natural log e is equal to 1, so I won't even write it. Now solve for t. T is equal to natural log 0.5. Natural log of decimal numbers is always a negative number. Anyhow, 0.5 natural log divided by 0.002 minus is equal to 346.5. 346.57 years. So it would take 346.57 years for this item, whatever it is, some compound, whatever, to decay to half of its original amount at a rate of 0.002, whatever that means. We're just looking here at algebraic expressions in terms of exponential applications. But look over here, this minus indicates that something will become exponentially less with time. The positive would mean something will become exponentially more with time. Anyhow, this right here was the most important thing you needed right here, utilizing this. What time is needed for half? Alright, this to convert everything here with regards to one variable. This here is a different variable, this here is a different variable, but this expression allows you to convert everything into one variable, because I'm not giving you what these amounts are, you're just using algebra to simplify it. The variables cancel out by this and you're left with 1 over 2. Why is natural log of a decimal number like this always negative? Think about the natural log curve. This right here is 1 comma 0. Your curve goes from here, it never touches the 0, but from 1 it's becoming large. It is between this part right here, from 0 to 1, you'll have all of these negative values in terms of your range. If ever you put a natural log of any number between 1 and 0, not including those, you'll have negative values, because when you put them on the calculator, you're looking at the negative y values of this function, which translates into a negative value here on your calculator. Thank you for watching. Have a nice day.